Hello students, in this video we will do the complete revision of reflection of light chapter for class 10 CBSE. So basically what is reflection? When light goes from one medium to another medium, then some part of it bounces back to the same medium, or you can say when light falls on a shiny smooth polished surface, then it bounces back to the same medium, and this phenomenon is called it reflection. Basically we see everything, most of the things around us due to the reflection of light comes from a source and falls on an object, and after that it bounces back and reach to our eyes and we can see the object. So basically it is the bouncing back of light. Reflection is the nothing but it is the bouncing back of light. Okay, bouncing back of light in the same medium. So we can represent the reflection of light by a diagram. So for the surface on which reflection occurs, or the surface on which light strikes, you can say it as a reflecting surface. You can say it as a reflecting surface. So I draw here a reflecting surface. So you can write here the name of this surface is reflecting surface. Okay, this is the reflecting surface where reflection occurs. The surface where reflection occurs. Now the light strikes or light falls on the reflecting surface, and the light ray which falls on the reflecting surface, that is we call it incident ray. Already you know it, you have studied in junior classes. This is incident ray. And the light which bounces back, the light ray which bounces back, we call this reflected ray. We call it reflected ray. Okay, reflected ray. And the point at which the incident ray strikes this particular point, this point is called the point of incidence. This point is called the point of what? Point of incidence. Okay, and if we draw a perpendicular line on the reflecting surface which is passing through the point of incidence, that imaginary line, that imaginary perpendicular line is called the normal. So here the when it is an imaginary perpendicular line, on the reflecting surface which is passing through the point of incidence, that is called it normal. That is what it is, normal. And you can see, you can notice here, if AO is the incident ray and OB is the reflected ray, so this AO, this incident ray, is making an angle with the normal, that is angle AON. This angle AON, and this angle is called angle of incidence. So the angle, an incident ray makes an angle with the normal, and this angle is called the angle of incidence. And similarly the reflected ray, you can notice here, this OB or BO makes an angle with the normal, and this is what BON, this is the reflected ray. So we'll write here angle AON, this is angle of incidence, we represent by the letter I. Okay, or angle of incidence. And here the angle BON is the angle of reflection. So we have learned few terms, and already we have studied in junior classes the few terms related to reflection, that is incident ray, that is reflected ray. Okay, point of incidence, this is the imaginary perpendicular line passing through the point of incidence, that is normal. And the angle between the normal and incident ray, angle of incidence, represented by I. And the angle between the reflected ray and the normal, that is what? Angle of reflection. And now we will study, we will do the revision, that is few laws of reflection. Laws of what? Reflection. So when reflection occurs, it obeys, it follows some rule, some law. So that is the known as the laws of reflection. So what is the first law? According to first law, angle of incidence is always equal to the angle of reflection. It means I equals to R. It means if you increase the angle of incidence, then the angle of reflection will be increased. Okay. Similarly, if you decrease the angle of incidence, angle of reflection will be decreased. So angle of incidence and angle of reflection is always key same, is always same. So that this is the first law. If the angle of incidence, if you take angle of incidence 30 degree, so the angle of reflection will be 30 degree. Okay, so this is both are same. Suppose you take the angle of incidence 60 degree, so what is the angle of reflection? 60 degree. So angle of incidence and angle of reflection is always same, and this is the first law of reflection. Now the second law, according to the second law, the incident ray, reflected ray, and normal is always lie, in the same plane at the point of incidence. Same plane means what? Suppose if you, look at the corner of your room, you will see that the three planes are meeting at the point. So if the incident ray in a, in a particular wall, or on the roof, so the normal and the, the reflected ray will be in the same plane. Or you can take an example. Suppose you take your, so straight your palm, so you will get the incident ray, reflected ray, and normal, all the, ray and the normal, on your palm. So this is basically a single plane, and you will get the incident ray, reflected ray, and normal on your palm. So basically, according to second law, incident ray, reflected ray, and what, and normal lie in the same plane, at the point of incidence, at the point of incidence. Okay, so this is the, basic of reflection of light. uh, we have discussed what is reflection, and we have, discussed the basic diagram, terms related to reflection, and laws of reflection. Now we will study in your syllabus, it is, after that it is given about the spherical mirrors. So already we have studied the plane mirror in junior classes, so we will not discuss the plane mirror in this video. But now we will discuss about the spherical mirrors. So everyone give the headline, spherical mirrors. uh, so what is spherical mirrors? What is spherical mirrors? Write the headline, spherical mirrors. Already we have studied the plane mirror. Plane mirror means the, the mirror is a plane surface. So from here you can easily know that spherical mirrors. So obviously the, spherical mirror means the mirrors are the part of a sphere. Suppose if you take a football, here it is a football. Imagine football, and you are taking a part of this football. Suppose this part, I am taking this part, okay, this part, and we are using this part of the sphere as a reflecting surface, then we call it spherical mirror. Okay, so it is a curved surface, it is a part of a sphere, and we are using as a reflecting surface like this. Okay, and we can use two sides, as we can use the inward portion as a reflecting surface. Here the light is striking, okay, this is the inward portion as the reflecting surface, or cave portion, or curved inward portion as a reflecting surface. Okay, so this type of reflecting surface, and this type of mirror we call it concave mirror. What mirror? This is concave mirror. Why concave mirror? As we are using the cave portion, inside portion, inward portion, curved inward portion as the reflecting surface. So this is the concave mirror, and the, outside portion or curved outward portion is, here it is, silvered, or you can say coated, silvered or coated. The outward portion is coated, and this curved inward portion or cave portion we are using as a reflecting surface. So this is called concave mirror. Similarly here, if we use, here the same part, it is also the part of sphere, but here different is, we are, giving the, coating inside, inward the curved portion, and we are using the reflecting surface, the bulging portion or curved outward portion. This is the reflecting surface here. This is the reflecting surface. So the bulging portion or the, curved outward portion we are using here as a reflecting surface, and inward portion is coated here. Here inward portion is coated, or you can say silvered. So this type of mirror is called convex. This is called convex. So I hope it is clear that which one is concave and which one is convex. Both are the part of the sphere. But if we use the cave portion, or what cave portion means this portion as a, the reflecting surface, cave portion, or the curved inward portion, then we call it concave. And if we are using this outward portion or bulging portion as a reflecting surface, then we call it convex mirror. Okay, now we are going to study some important terms related to the spherical mirror, some important term related to the spherical mirror. So first we will study pole. So I am drawing two mirrors. So suppose here it is a concave mirror, and here It is a convex mirror. Concave mirror, so reflecting surface is cave portion or inward, curved inward portion. Here the reflecting surface is curved outward or bulging portion. So we are drawing here. This is the concave mirror. This is the concave mirror, and this is the convex mirror. Okay, now we will study the important terms related to the concave and convex mirror, spherical mirrors. So what is pole? What is pole? Basically, mirrors are the reflecting surface. So this reflecting surface, the center of this reflecting surface, the center of this is not defined by p, by c. The center of this reflecting surface, it is called pole. This is the reflecting surface. So this reflecting surface has a center, and this center is the called pole. So it is basically the center of the reflecting surface is pole. Now we will study the center of curvature. Center of what? Center of curvature. So what is center of curvature? Basically, already we know that the mirrors are the part of a sphere. So we can draw an imaginary sphere. We can draw an imaginary sphere. Here is also we can draw an sphere. So here, the center of this sphere, this sphere has a center. So center of this sphere is called center of curvature. It means, the center of the sphere of which spherical mirror is a part, that center is called the center of curvature. Okay, now and we represent by the letter C. Now see the radius of curvature. The radius of what? Radius of curvature. So what is radius of curvature? It is also easy that the obviously the mirrors are the part of sphere, and the radius of that sphere, radius of the that sphere, radius of the sphere of which spherical mirror is a part, that is we call it the radius of the curvature. Like this sphere, radius of curvature for this mirror. Here here it will be P, not C, as it is pole, center of the reflecting surface, pole. So here it is radius of curvature. Clear? So radius of the sphere of which spherical mirror is a part is called radius of curvature. Center of the sphere of which spherical mirror is a part is called the center of curvature. Okay, so we have completed it. Now the important thing is that principal axis. Principal axis. What is this axis, sir? What is this axis, sir? Principal axis. So what is principal axis? Basically, principal axis is an imaginary line which is passing through the center of curvature and pole. It means this line, center of curvature and pole, this is the principal axis. So an imaginary line which is passing through the center of curvature and the pole. Here is also, center of curvature x and x dash. So this is the principal axis. So I have written x dash. So it is nothing but it is simple that it is an imaginary line which is passing through the center of curvature and the pole. That is the principal axis. Now 5. That is the principal focus. That is the principal focus. That is the principal focus. So what is principal focus? We represented by the letter capital F. So when the light rays parallel to the principal axis, when the light rays parallel to the principal axis fall or strike on a mirror, then what will happen? Here is also suppose fall on a convex mirror, strike on a convex mirror, and strike on a concave mirror. Then what will happen? For concave mirror, it meet at a fixed point on the principal axis. It meet at a fixed point on the principal axis. Here is also. So and this fixed point on the principal axis where the light ray meet for a concave mirror, or another fixed point from where for concave mirror it appear to meet, it diverge, actually it diverge, okay, parallelly, but it appear to meet from the fixed point on the principal axis, and that fixed point on the principal axis is called the principal focus. So when the light rays parallel to the principal axis strike or fall on a concave mirror, then after reflection it meet at a fixed point on the principal axis, or for a convex mirror it appear to meet from a fixed point on the principal axis, and that fixed point is called the principal focus. I hope it is clear. Now the next thing is that important thing is that focal length. Focal length. So what is focal length? What is focal length? Basically the focal length is the distance between the pole and the focus. Distance between the pole and focus. So here distance, this is the this is the focus. We have studied this is the focus, this is the focus. So this distance is f. So it is the distance between pole and focus we represent by f. Actually distance between what? Distance between uh, distance between distance between pole and distance between the pole and focus. Distance between pole and focus is the focal length. Okay, now we will study the important relation. Now we will study a, an important relation between the focal length and the radius of curvature. So we have an important relation between focal length and the radius of curvature, that is f equals to r by 2. F equals to r by 2. It means if suppose I consider a concave mirror of radius of curvature 50 centimeter, radius of curvature 50 centimeter, then what will be the focal length of that mirror? So obviously that will be r by 2. It means 50 by 2. So that will be 25 centimeters. So this is the important formula we have to remember, that f equals to r by 2. Okay, so this is the important terms related to spherical mirror we have studied. Now we will study the image formation by spherical mirrors. So to know the image formation, types of image, the position of the image in detail, we have to study the ray diagram. But as we have very less time, we are doing the revision in this video, so we will not, will not discuss the complete detailed ray diagram in this video. But if you are interested to see the complete detailed video on ray diagram, then you will do the comment. I'll try to make the video on this topic. Now we will study the image formation by a spherical mirror. Image formation. Okay, concave concave mirror. So now we will study the image formation by spherical mirror. First we will study the image formation by concave mirror. We will not study the detailed ray diagram in this video, but we will do the revision of different types of image we get from the concave mirror. Okay, by the concave mirror. So first we will draw a concave mirror. Already you know the drawing of concave mirror. So this is a concave mirror, and this is the principal axis of the concave mirror. This is the pole of the concave mirror. This is the center of curvature of the concave mirror, and this is the focus of the concave mirror. Now first we will put the object beyond C, and beyond C to infinity. Suppose the name of the object is AB, so we will get the image between C and F, that is B dash and A dash, and the nature of the image is real, inverted, and you can see the inverted image, and it is a diminished small size image than the object. Now if we keep the object at C, like D, E. So we will get the image at the same position at C. So D dash and E dash, and it is real and inverted. Now if we keep the object between C and F, like suppose GH, I am giving the name. So we will get the image beyond C, and it is the enlarged real inverted image, H dash and G dash. Okay. Now if I keep the object at focus point, at focus, okay, suppose I am giving the name. So if I keep the object at focus, we know that the image will be formed at infinity. Okay, image will be formed at infinity, image will be formed at infinity. Now if we keep the object between focus and the pole, between focus and the pole, suppose KL, so the image will be inside the mirror, image will be inside the mirror, and this is the first virtual image we got. So the only position for a concave mirror, that is between pole and focus, we got a virtual image, virtual erect image, virtual erect and enlarged image, virtual erect and enlarged image. So this is the only position for a concave mirror, that when we keep the object between pole and focus, we get a virtual, enlarged and erect image. Now another position is left, that is if we keep the object at infinity, if we keep the object at infinity, if we place the object at infinity, then we will get the image at focus, and that image will be very very diminished, like you are taking the image of a sun, using your concave mirror. So that image will be very very diminished, real and inverted image. So this is the the complete image formation by concave mirror, depending on the position of the object. Now we will study the convex mirror. Okay, so first we will draw the convex mirror. Okay, this is the convex mirror where the reflecting surface is curved outward. Okay, I have drawn properly. Now here pole, here is the focus, and here is the center. Here the focus and center is inside the mirror, so this is interesting. So we do not need to define the position of the object at different place, as already focus and center is the inside the mirror. So here is only position we have, that the object is between pole and where? Pole and infinity. Object is suppose AB object, and this is anywhere between pole and focus. always we will get the image between pole and focus, and this is virtual erect and small size image, virtual erect and diminished image, or virtual you can say upright image. So you know, wherever we place the object between pole and infinity in front of a convex mirror, we always get the image between pole and focus, and it is virtual and erect image, okay, and smaller size. Now if we keep the object at infinity, if we keep the object at infinity, so we will get the image at focus. Like similarly for concave mirror, we get the image at focus, and that is real image for concave mirror. But for convex mirror, we always get virtual image, and you already know it. Real is always with inverted, and virtual is always with erect. So in convex mirror, we always get virtual and erect image. In concave mirror, we only get, when the object is placed between pole and focus, only at that time we get the only at that time we get the virtual and erect image. Okay, now we will study the and no study the important relation between the object distance, image distance, and the focal length. But before studying it, we will discuss some applications or uses of concave and convex mirror. It means the uses of spherical mirrors. So concave mirror, we have studied that if we keep the object between the pole and focus, it forms the enlarged direct image. And using this property, we use the concave mirror as a makeup mirror to see the bigger face, bigger image of our face. Similarly, we can use for a shaving mirror. And another thing is, doctors used to see the a large image of our teeth, large image of our teeth. Doctors, sometimes doctors head mirror use as and you can see that the in cars headlight is used as a concave mirror used as a the reflectors. So these are the uses of the concave mirror. And similarly, the uses of convex mirror, as you know, the convex mirror has a wider field of view. It forms the virtual erect and small size image, so that we can use the convex mirror as a car viewfinder, shop security mirror, or road safety mirror. These are the uses or applications of spherical mirrors. Now we'll study the important relation between the image distance, object distance, and the focal length, and this is called the mirror formula. So everyone write in mirror formula. Mirror formula, this is important, very very important formula. Okay, so 1 by v plus 1 by u equals to 1 by f. What is this? V is equal to said image distance. It means, the position of the image, the distance of the image from the pole. And u, what is u? U is the object distance. U is the object distance. Okay, and what is f? F is the focal length. F is the focal length, that is the distance between the pole and the focus. That already you have studies. Now focal length. Okay, so 1 by v, 1 by u, we got it, the formula. This is the important relation. Now we have another terms we have to study, that is the magnification. What is magnification? Basically this is the ratio. This is the ratio of image height to the object height. So why do we calculate the magnification? Know that the image size is how much bigger or smaller than the object to compare the size with the object size. So it is the ratio of image size to the object height, hi by ho, so that we can compare the image size with the object height, how much it's smaller or larger, it's smaller or bigger than the object. And we can also prove that we can write minus v by u. For it we can prove it, minus hi equal to hi by ho, height of the image divided by height of the object, equal to minus v by u. Okay, we can write it. Now here, if suppose m greater than 1, it implies that h it means hi, height of the image greater than height of the object. It means obviously we get a bigger image, a large image. That's why the height of the image greater than height of the object. So if m greater than 1, it means we get an enlarged image or bigger size image. If m equals to 1, it means hi equals to ho. It means we get a same size image. Okay, if now m less than 1, it means hi less than ho. It means height of the image is less than height of the object. And it means if m less than 1, we get a smaller size image. Clear? So okay, Now we will study whenever we will substitute the value. Whenever we will substitute the value in the formula, we will use the sign convention rule. There is a sign convention rule. So before substituting the value in the formula, we have to use the sign convention rule. So now we will study the sign convention rule. The sign convention rule. So write it, sign convention rule. Sign convention rule. So before substituting any value in the formula, we have to follow this sign convention rule. So we'll use some sign convention rule. Suppose I am taking a concave mirror, and this sign convention rules applicable for both the mirror, both the spherical mirror. Okay. Uh, or maybe the plane mirror. So here I am taking as example, I am taking a concave mirror. So first question arises that from which point we have to measure all the distances. So the first thing is that we have to measure all the distances from the pole of the mirror. So we will measure all the distances from the pole. Any distance, maybe object distance, maybe image distance, we always measure from the pole. Okay. Now this is, suppose this is the direction of light. This is the direction of light. This is the direction of light. Okay, so if we are measuring any distance in the direction of light, okay, along the direction of light, at that, so that this distance will be positive. So along the direction of light, if along the direction of light, along the direction of light, measuring any distance along the direction of light, we will take it positive. It means we have to measure from the pole, and along the direction of light we will take positive. It means the right side, right side of the mirror, right side of the pole is positive. Obviously this is along the direction of light. If the against the direction of light, if it is against the direction of light or opposite the direction of light, we will take as negative. Take as negative. So it means left side of the mirror, left side of the pole, this side is the negative. So suppose say me, this is the object. So object distance we are measuring from pole, and it is against the, opposite the direction of light. So object distance, you always what, you always, negative. Remember it, you always negative, as it is opposite the direction of light. Now if we measure the, above the principal axis, any, above the principal axis, above the principal axis, suppose I named it xx dash principal axis. So any, any length, any distance above the principal axis, suppose the height of the image, height of the object, suppose this height of the object, so this is above the principal axis, so it is positive. Okay. And suppose, below the principal axis, below the principal axis, below the principal axis, suppose here an inverted image, created inverted image. So here it is below the principal axis, so it is negative. So simple it is. If we are measuring the distance along the direction of light, we will take it positive. If against the direction of light, we will take it negative. Or in simple, you can remember that, right side of pole is positive, left side of pole is negative. Above the principal axis positive, below the principal axis is negative. So simple, it's very simple and clear. Now can you say me, for, the, for magnification, suppose we have studied the magnification, that the formula is height of the image divided by height of the object, or minus v by u. And we have studied, the, now say me, height of the object, height of the object, it is always what, always positive. It is always positive or not? Height of the object, height of the object, height of the object, not the distance of the object, it is the height of the object. So height of the object obviously above the principal axis, so it is always positive. Now height of the image, now height of the image will be positive if it is a virtual image. So virtual image means above the principal axis. So at that time, it is always positive. And hi is positive when virtual image, and the value of m will be what, the value of m will be also positive. Value of m will be positive if the image is virtual. Okay. And if image height, in negative, image height negative, it means it form the real image below the principal axis, and here negative, and below it is always positive, so the magnification value will be in negative. So this will indicate the real image. So if we got the value of magnification in positive, then it is obviously the virtual image. If we got the value of magnification in negative, so it is the real image. Okay. Now we will solve a numerical, uh, based on this formula. Okay, so now we'll solve a numerical. Write a question. A concave mirror has focal length focal length 20 centimeter. An object is placed at a distance 10 centimeter in front of the concave mirror. Now calculate the image distance and the magnification. So here we have to calculate the magnification and image distance, and to solve a numerical, our first step is to write the given data, and we have to write the given data with the proper sign convention. So first is focal length given here, and that is the value is 20 centimeter. But what will be the sign? Is it positive or negative? So as it is concave mirror, and the focus point is in front the mirror, so it is against the direction of light, so f is here what, negative. For concave, for convex it is along the direction of light, so for convex it is positive, focal length is positive, remember it. So we have to write the focal length with the proper sign, that is minus. And object distance is always what, object distance is always negative, so we'll write minus 10 centimeter. Now asks for v, so we'll write the formula, mirror formula, that is we know 1 by f equals to 1 by v plus 1 by u, or from here we can write 1 by v is equals to 1 by f minus 1 by u. Now we will put the value 1 by f minus 20 minus of 1 by u, so minus of 10, so you can write 1 by 10 minus of 1 by 20, 1 by v equals to, or 1 by v equals to, you can write 20, 1 by 20, or v equals to 20 centimeter, and it is in positive, it is in what, it is in positive, so we'll get the image at a distance of 20 centimeter inside the mirror. So if this is the concave mirror of focal length of what, 20 centimeters, so that this is suppose 20 centimeter focal length, 20 centimeter focal length, and object is placed at 20 what, 10 centimeter, 10 centimeter, so we will get the image 20 centimeter, 20 centimeter where, plus it means inside the mirror, okay, 20 centimeter inside the mirror here, 20 centimeter. And now if now ask for the magnification, so here magnification v value we got it, plus 20 centimeter, and we know the formula magnification minus v by u, so minus of 20 divided by minus of 10, so minus minus eliminated, so the magnification value is 2, and it is plus means what, plus means it is virtual, already we have studied it, and 2 means magnification, 2 means the image size will be 2 times the object size, so we will get an enlarged image, we will get an we will get a magnified image, and the image size will be 2 times than the object size. So this is the complete video, complete rapid revision of reflection of light chapter for class 10 CBSE. I hope you have learned something, you did the revision from this video. If you like this video, if you learned something from this video, you can like this video and share with your friends. Thank you for watching.